Chapter 2, Section 3. Today we're going to study about the lines. So there are a lot of contents in this section, okay? You can read through all the objectives of this section. So first, let's talk about the slope of the line and how to interpret the slope. Slope defines as rise over run, okay? Rise refers to the vertical change, run refers to the horizontal change. Okay, so the ratio of vertical change and horizontal change is called the slope of the line. So if we put into a formula, okay, let's make some proper notation first. So let P and Q be any two distinct points on the line. Okay, x1, y1 denote the P1 denoted by x1, y1, and then the point Q denoted by xy2. And then slope can be calculated by rise, which is the vertical changes of the 2 points y coordinates. Okay, the run is calculated by the difference between the 2 points x coordinates. So the ratio of these two changes we call the slope. Okay, so the slope, another way to interpret is how many units rise, okay, over the number of units of run. Or in other words, is how fast the line is climbing, either upwards or going downwards. So here we require the 2 points x coordinates is not the same. Okay, we say it's a two distinct point. Okay, if x1 equals x2, okay, if the 2 points x has the same x coordinates, and then the line we call it vertical line. Okay, if that is the case, and then we say the slope is undefined because this denominator equal to 0. The whole expression is undefined. Okay, so you need to remember that as a theorem. Later we're gonna talk about this again. Vertical line has undefined slope. Okay. So that's the graph just illustrating again. Okay, what is the rise, what is the run, and then slope is the ratio of the two. Okay, and then B is showing you the special case when x1, x2, which is 2 points x coordinates, they're identical, and then that's represent a vertical line. Vertical line has a undefined slope. This graph is repeating the same thing. Okay, rise, that's the vertical changes of 2 points y coordinates. Run is the horizontal changes, can be calculated by find the difference between 2 points x coordinates. So now let's look at an example. Okay, how to find the slope of a line given 2 points. So if we denote as x1, y1, the other point we denote as x2, y2. It doesn't matter which point you denote as first point, which one you denote as second point. Okay, so the slope equals either y1 minus y2 over x1 minus x2, or you can write as y2 minus y1 over x2 minus x1. Okay, which point y coordinates subtract the other actually doesn't matter as long as it's consistent. Okay, if you find a rise, you use 1 point y coordinates, subtract the other point y coordinates, and then run, you use the same order. Okay, and then that's how to find the slope of a line. So let's find the slope of the line passing through these 2 points. Okay, so the book used the y2 minus y1, and I will do y1 minus y2. Okay, just let you see they are actually getting the same result. So slope equals y1 minus y2 over x1 minus x2. Rise over run. Okay, so that's y1, that's 2, right? y1 minus y2 minus negative 3 divided by 1 minus 5. So numerator minus negative become a positive 5. Denominator is negative 4. Okay, so slope equals negative 5 over 4. So this negative sign you put on the numerator or put on the denominator or put in the middle, they are exactly the same. Okay, there's no difference. But as the final result, normally we put a negative sign in the middle. So how to interpret the slope? That means every 4 units change in x, okay, y will change by negative 5 units. Okay, every 4 units change in x, and then negative 5 units change in y. Or you can do the other way around. Every negative 4 unit change in x, y will change by positive 5 unit. Okay, either way, again, this negative sign you can go on the top or go to the bottom or put in the middle. Okay, they represent the same. The only thing different is how you interpret. Okay, it could be different. So the value of the slope, does that make any difference? The answer is yes. Okay, the value of the slope does represent different types of line. So let's look at this graph. Okay, this is one of the line. Okay, in the pink color, slope, if we calculate it, equals 5 over 3, which is a positive number. Okay, L2, orange color, the slope is negative 4, and then you can see it's this kind of line. Okay, and then the blue line have slope 0. So what kind of line can you tell? It's a horizontal line, isn't it? And then green line, line 4, the slope is undefined. So this represents the 4 typical value of slope. Okay, if I put in a kind of a table, okay? If slope is a positive number, okay, positive slope, and then the line is always going upward, okay, so that means x move from left to right, okay, the y is moved from bottom to up. So we call this kind of line, we call the increasing line. Okay, this is the increasing line. So if slope is a positive, line is always climbing upward. So this kind of line we call increasing line. If slope is a negative, okay, we call the line is decreasing. So line will look like this way. Okay, as x move from left to right, and then is actually going downhill. Okay, this kind of line we call it decreasing line. So decreasing line means the slope is a negative. And then two special type of line. If slope is 0, that's represent the horizontal line. Okay, horizontal line. All the horizontal line, the slope must be 0. Okay, and another special line we already mentioned earlier is the vertical line, which is slope is undefined. Okay, vertical line have undefined slope, and other line have undefined slope must be vertical lines. Okay, so that's the 4 typical value of slope, represent 4 different types of line: increasing line, decreasing line, horizontal line, and vertical lines. And then this is actually a theorem. Okay, when the slope of a line positive, and then the line starting upward from left to right, slope of line is negative, and then the line slants downward from left to right. Okay, and when the slope is 0, line is a horizontal. When slope is undefined, line is vertical. So what if all the lines are increasing lines, can we use the value of slope to determine which line is going uphill more faster? Yes, we can. Okay, let's compare this group of increasing line. Okay, they're all going uphill, right, upward, but the value of slope is different. So you can see from the y1, which is horizontal line, slope is 0. Okay, to y2, slope is 1/4. To y3, slope is 1/2. To y4, slope is 1. Okay, and then to y5, slope is 2. y6, slope is 6. So you can see as the slope increase, okay, as slope increase, actually the line is going uphill faster, which is represented as it's more close to the y-axis. Okay, the line is more close to y-axis. So as the value of the slope increase, the line is going uphill, more steepened, and the line is more close to y-axis. And then what if a group of negative slope or decreasing line? Okay, can we use the value of slope to determine how fast it's going downwards? Yes, we can. Okay, let's look at this group of line. Same y1 horizontal, okay, y2 slope -1/4, y3 slope -1/2, y4 slope -1, y5 slope -2, y6 slope -6. So this time is as absolute value of the slope increase, and then the line is more close to y-axis. Okay. As the absolute value of slope increase, the line is more close to y. So positive line, negative line, actually we can, draw the same conclusion. As absolute value of the slope increase, the line is going either upward or going downwards more faster, and then the line showing up to be more close to the y-axis.